Well, in section 2 here, we're going to learn how to add and subtract radical expressions. And when adding and subtracting radical expressions, it's just like adding and subtracting monomials. We can only combine like terms. And in this case, we're only going to be able to combine like radicals. What do I mean by that? Well, that means the radicands have to be the same. In other words, in number 1 down here, we have a radicand of 5 and a radicand of 5. That means I'm going to be able to add these guys together. And what we're going to end up doing is we're going to be adding or subtracting the coefficients. But we'll end up keeping the term, or in this case, the radicand would keep the term the same. So in number 1, we have 2 radical 5 plus 4 radical 5 is 6 radical 5. Well, now keep in mind that what we're doing is we're just adding things. And what are those things? Well, it's whatever we're adding together in the first place. So, for example, when we were talking about adding monomials, well, the 3x plus the 5x, for example. The terms, in this case, the x's, those are the things that we have. Remember that the coefficient tells how many things that we're talking about, how many things we have. How many of them are there? Well, in this case, there are 3. We have 3 x's. In this case, there are 5. There are 5 x's. What do you get when you add 3 x's and 5 x's together? You have 8 x's. So the answer would be 8x. Well, that's all well and simple, but it turns out to be a little bit different when we have fractions, because we forget what coefficients are. Well, what is the coefficient of x in this case? That's right, it's 1. How about in this case? 5x. Well, the coefficient is 5. In fact, every time you take out the variable, you'll have the coefficient. So, for example, in this case, how about, get my pen back. How about we have 3x over 7? Well, the coefficient is 3/7. How do I know? Well, I take out the x. Whatever's left over, that's your coefficient. So in this case, it's 3/7. But what if we had 3/7 x, or 3x over 7, and I want to add to it, say, 2x over 7? Well, we add their coefficients. 3/7 plus 2/7 is 5/7 x. Now notice where the x is here. It's in the numerator. The x here is in the numerator, but here I put it off to the side behind the 5/7. They mean the exact same thing. So 3/7 plus 2/7 is 5/7. Or let's say we had something like this. How about x over 9? What's the coefficient? It's 1/9. Why? Because there's a 1 in front of that x. When I take out the x, I'm left with 1/9. So the coefficient here is 1/9. So if I had 1/9 x plus, say, 6x over 9, I could add the coefficients. 1/9 plus 6/9 would be 7/9 x. So hopefully now you have a little bit better understanding of what we mean when we're adding and subtracting coefficients. In number 2, we have the radical 3 and the radical 3 that are the same. I add the 2 and the 3 and I get 5 radical 3. In number 3, only the radical 3's get combined. I'm going to jump over the radical 6 for the time being. I have 2 radical 3 minus 5 radical 3 is negative 3 radical 3. I bring down the plus radical 6, and we're done. But in number 4, we have radical 60 and radical 135. Well, that doesn't make a whole lot of sense. because we can never, ever take 60 and subtract 135. That's not going to happen. What we are going to do is simplify radical 60. Now, it's important, and I'm telling you right now, class, I've been doing this for a long time. Trust me when I say what you need to do here is rewrite this problem from beginning to end, only simplifying radical 60, meaning this, write down that 2. Write down the radical with all the prime factors of 60. And what are the prime factors of 60? Well, we have 2, we're going to get 30 divided by 2. We get 15, divide that by 3, and we get 5. So we have 2 times 2 times 3 times 5. And then minus 5, don't forget to write that down, times the radical of 135. Well, what are the prime factors of 135? Well, if I divide that by 3, I get 45. Divide that by 3, I get 15. Divide that by 3, and I get 5. So 3, 3, 3, and 5. All right, so we have this 2 that we need to bring down. And then I'm going to be able to pull out a 2 here. And I have radical 3 times 5 left over. Minus, please don't forget to write down that 5. And then I have underneath the, I have times 3 because I'm going to be able to pull that one out. And left in the radical, I'm going to have 3 times 5. Well, it's important to remember, the class, that numbers outside the radical stay outside the radical, and the numbers that are inside stay inside. So the numbers that are outside here get multiplied together. I'm going to get 4. The numbers that are inside get multiplied together, and I get radical 15. And I bring down my minus sign. I take 5 times 3 and get 15. And then 3 times 5 and get 15. And it's important to remember that the numbers inside stay inside. The numbers that are outside stay outside. Now I'm subtracting 2 numbers that have radical 15s as their terms. I'm going to take 4 minus 15 and get negative 11, radical 15. In number 5, radical 8x can be simplified. Do you remember what it is? 2 radical 2x. And then I have minus radical 2x and plus 5 radical 2x. Well, do you remember what the coefficient is for the first term? Right, it's 2. Do you remember what it is for the second one? It's minus 1. There is a 1 in front of that radical 2x. Don't forget that. And we're going to take 2 minus 1 is 1, plus 5 is 6, 6 radical 2x. 2 radical 5 minus 5 radical 5 is negative 3 radical 5. In number 7, we take radical 80, and we're going to need to simplify that. Now, I see, here's what I see, class. I see 80 as 16 times 5. Why 16? Because 16 is a perfect square. It's the largest perfect square that can go into 80. And then minus radical 20 is 4 times 5. And then for 180, I see plus radical 36 times 5. I can take the square root of 16 and get 4. I have 4 radical 5 minus the square root of 4 is 2, 2 radical 5, and the square root of 36 is 6 radical 5. 4 minus 2 is 2. 2 plus 6 is 8. 8 radical 5 would be your final answer. Number 8. We just found the square root of 80. It's 4 radical 5. We don't need to do that again. But don't forget to bring down the what? The 3. So I'm going to have 3 times 4 radical 5. And then minus the 5. See, I'm writing down the entire problem the entire way. Even though I'm not using the 3 at this point, I need to bring it down, otherwise I'm going to forget about it. We know what radical 20 is. It's 2 radical 5. So I bring down times 2 radical 5. Bring down the plus 2. I'm writing the entire problem down. All parts of the problem get brought down, because class, if you don't, you're going to forget. And 18 is going to be 3 radical 2. I multiply the 3 times 4 and I get 12 radical 5. I take 5 times 2 and I get minus 10 radical 5. And I take 2 times 3 and I get plus 6 radical 2. What are the like terms? 12 radical 5 minus 10 radical 5 can be combined. I get 2 radical 5 plus 6 radical 2, my final answer. Radical 12, what's that? Well, the square root of 12 would be 2 radical 3 plus 48. Do you see it yet? All right, let's take 16 times 3. So 2 radical 3 plus 4 radical 3, 6 radical 3 is your final answer. 2 radical 3 plus 6 radical 5. Radical 3, radical 5, not the same. This is simplified. Your final answer would be 2 radical 3 plus 6 radical 5. Nothing changes. Here we have negative 5s. That are the terms. You take negative 2 minus 6, you get negative 8, radical 5. In number 3, negative 2 times 6, because the square root of 36 is 6. Plus 5 times 2, because the square root of 4 is 2. Negative 2 times 6 is negative 12. Plus 5 times 2 is 10. Negative 2, final answer. And number 4, again, having to simplify the square root of 75, I'm going to have 3. I'm going to definitely bring down that 3. 75 would be 25 times 3, and then plus 2 radical 5, because that can't be simplified anymore. Well, the square root of 25 is 5, so I'm going to have 3 times 5 outside and radical 3 on the inside, plus 2 radical 5. 3 times 5 is 15, radical 3, plus 2 radical 5. Final answer, because the 3 and the 5 can't be combined. I should say radical 3 and radical 5. In number 5, I have negative 2 radical 2 minus 3 times 5 minus 4 times radical 32 would be radical 16 times 2. Negative 2 radical 2 minus 3 times 5 is 15 minus 4 times 4 radical 2. Negative 2 radical 2 minus 15 minus 16 radical 2. Negative 2 radical 2 minus 16 radical 2 is negative 18 radical 2 minus 15. Final answer. Bring down the 4 in number 6, and then radical 45 would be radical 9 times 5 plus 2, bring down that 2, and then radical 80, we found out what that was earlier, I believe, right? Radical 180. We already did the work for this. It's 6 radical 5, right? So we don't need to show that work anymore. We've already done it once. So 6 radical 5. We have 4 times 3 radical 5 plus 2 times 6 radical 5. 4 times 3 is 12 radical 5 plus 2 times 6 is 12 radical 5. 24 radical 5 would be your final answer. In number 7, with 250, here's what I'm seeing. I'm seeing 25 times 10 AB minus, and the 90 is 9 times 10 AB. The square root of 25 is 5 radical 10 AB. Minus the square root of 9 is 3 radical 10 AB. The 10AB, radical 10ABs can be combined, so 5 minus 3 would be 2 radical 10AB. Final answer. Oh my, number 8, we have fractions, dear me. Well, it helps, like I've been saying all along, to write down the entire problem. Bring down the 1/5 and simplify radical 8. We've done that. 2 radical 2. Plus Radical 32. Let's see now, what would that be? Square root of 16 times 2? So 4 radical 2, right? Well, let's see now. When you take it, and looking at this first term, I have 1/5 times 2. What would that be? 2/5 radical 2 plus 4 radical 2 over 5. Well, it turns out these are like terms. How do we know? Because they're both radical 2's. The thing is, though, class, and we talk about this all the time, is what are the coefficients? Well, here it's 2/5. What is it in the second one? Well, it's 4/5. What do you do with coefficients? You add them together. What's 2/5 plus 4/5? 6/5. So we can write this 6/5 radical 2, or if you want, you can put the radical 2 in the numerator and get 6 radical 2 over 5. Either one is acceptable. In number 9, we have radical 12, 2 radical 3, plus radical 20 is 2 radical 5, plus radical 27 is 3 radical 3, plus radical 45 is 3 radical 5. The 2 radical 3 plus 3 radical 3 is 5 radical 3. The 2 radical 5 plus 3 radical 5 is 5 radical 5. Final answer. The radical 5x's cannot be simplified, but I can add them. 6 plus 9 is 15 radical 5x minus 4 radical 3x. Final answer. All right, so maybe you don't see the square root of 108 easily and how to simplify that. Maybe even the same thing with 75. So write out the prime factors. In 108, we take out a 2, we take out a 3, and we get 2 times 3 is 6 radical 3xy. Plus, now don't forget the 3 that we need outside the radical 3. I'm going to take it times 5, and I'll have 3xy left over. Stays underneath. 3 times 5 is 15. 15 plus 6 is 21. 21 radical 3xy would be your answer. In number 12, what's the answer? You should be able to come up with this one right away. It is not 14 radical GH. That is not the answer. Why? Because we have 14 of radical GH's here, and I'm taking how many of them away? 1. The answer, 13 radical GH. Good luck on your assignment, and we'll see you next time in class.